right, ladies and gentlemen, welcome back. Here we go. Moving on into unit number 3. Hopefully, I never change this from unit number 3. Today, we're going to be taking a look at atomic structure, ladies and gentlemen. For most of you, this is going to be some review from your middle school science classes. But first, we're going to break down an atom. We're going to start looking at subatomic particles. Make sure that you remember all of those fellers. Make sure you remember where they're located and a couple of things about them. Excuse me. Our subatomic particles we've got protons, we've got neutrons, and we've got electrons. All right, our protons we're going to abbreviate as P+, our neutrons is just a lowercase n, our electrons is that E with a small negative sign up top. So a couple of things that we need to know about these guys. Our protons, remember, they are found in the nucleus of our atoms. They determine the element ID, and they are actually equal to the atomic number on the periodic table. So if you take a look at a periodic table, which you should, go ahead and pull out of your chill book there. It is actually, if you look at that top number, that's our atomic number. That's how many protons. Notice, every element has a different number of protons. All right? The element identity is determined by the number of protons, guys. All right? Okay, our neutrons, moving on. In the nucleus, also with the protons, they are neutral in charge, and the only thing that they do is they change the mass. They change the mass of the elements. If we change the number of neutrons, we change the mass. Now, they do have some role in radioactivity of any particular element, but we will get into that later. All right, now moving on to our electrons. Our electrons, they are found in the electron cloud around the nucleus, so they are not in the nucleus, not all the time anyways, but they're found in the electron cloud around the nucleus. They have a negative charge, and so changing the number of electrons changes the charge. So a couple of things that you might want to really make sure that you got down there. On top of everything else, if we change protons, we change the element. All right, neutrons just change the mass if we change it, so you'll definitely want to know that, right? So change equals, we're just going to say change the mass. And then for our electrons, if we change the number of electrons in the element, we change the charge of any particular element. All right, and so let's really quick draw out an atom. I'm going to draw a Bohr's model of an atom, and so I've got a nucleus there. I'm just going to show the positive, and then we're going to draw rings around it. Generally, we're going to show electrons as dots in the ring. Now, if you missed the guy's name, this is called a Bohr model, or planetary model of an atom. The rings on this actually represent energy levels, and so the rings are energy levels, and the further the rings get away from the nucleus, the higher the energy level is. All right, and now just to confuse everybody, most of the time we refer to these as N. So N equals 1, and we call them principal energy levels. And so in this, we have a principal energy level N equals 1 and a principal energy level N equals to 2. Just to confuse you, all right, because the abbreviation for neutrons is also a lowercase n. So hopefully we do not get those confused, okay? All right, so moving on, we're going to take a look at how we change the charge of our atoms, all right? So the charge of the atoms, an atom is going to be neutral if the number of protons, let's put number, is equal to the number of electrons. It's going to be a positive, and I'm going to introduce a new word here, an ion, which means an ion is just something that is an atom that has a charge. And so if it's positive, the number of protons is not equal to. How about if I just go ahead and erase that all together, and we'll just say that the number of protons is greater than the number of electrons. And if we have a negative, let me change colors here. I think I put the same color there. If we have a negative ion, the number of protons is less than the number of electrons. And so you notice this, it looks like if you're just taking a guess here, one positive cancels out one negative. So whichever one I have more of, that's the overall charge of the atom. And if they are equal, we will call it neutral. But the term ion, the only thing that we're saying is we're saying, did we gain or lose electrons? Does it have a charge? Now, something I want to point out here too. A positive ion, it has more protons than it does electrons. Remember, our protons aren't going to change. And so how this happened is that we actually lost electrons if we have a positive ion. And then the opposite of that is true. If I have a negative ion, that means I gained electrons, right? Because remember, the protons don't change, and it's just this balance of positive and negative. All right, okay. So here we go. I got a clear screen now. I'm ready to go again. I'm going to take a look at a couple of things. Number one, I've got an Na+. And so if I look, you find Na on your periodic table. It's actually element number 11. So I've got 11 protons. And since this is positive, that means I have one, and this is positive 1. I'm going to interpret that as a positive 1. If I don't tell you a number up there with that charge, you're going to assume it's 1, which means I have 10 electrons. Because remember, if it's positive, I have more protons than I do electrons, and the size of that charge tells me how many more. All right? And so this would be a positive ion. All right? And then let's go ahead and take a look at another case. Let's just say I've got Na. In this particular case, I've got a neutral atom. So notice the terminology change now. If I have a charge, I've got an ion. If it's neutral, I've got just an atom. And so in this particular case, again, I've got 11 protons and 11 electrons. All right? Nothing crazy here. Now let's take a look at a negative one. Let's take a look at chlorine. If I've got chlorine as a neutral atom, right? If you find chlorine on the periodic table, you'll see that it's got an atomic number of 35, and so it's got 35 protons. Which means if it's neutral, protons is equal to electrons. So that means it's 35 electrons. And then let's go ahead and just get things jiggy here. We'll say now I've got chlorine. Let's say I've got a minus, chlorine minus. So I've got a negative ion. So remember with this, it means I had more electrons. And so I still have 35 protons because it's still chlorine. But in this particular case, since I've got a negative 1 here, now I've got 36 electrons. I've got one more. So that chlorine atom gained electrons there, right? And so we want to definitely make sure that we understand the difference here. If I'm looking at positive ions, notice I lost electrons. If I'm looking at negative ions, again, I gained electrons. So we want to make sure that we understand a couple of things. Number one, protons don't change. Positive ions lose electrons. Negative ions gain electrons, all right? Okay, and so what I'm going to do now is I'm going to go ahead and just jump over. You're going to see the screen pop up. I'm going to have a periodic table drawn here. I suggest you get it copied down too. All right, and so now we're back. I've got this periodic table drawn, and I just drew it freehand, ladies and gentlemen. It doesn't have to look pretty. It's got to have the same general shape. And get your columns in the right place. And notice I've got two groups here. We're actually going to ignore all of this in the center, so that's why I didn't draw anything there. We're going to ignore it for now. And what I'm going to do is I'm going to explain a couple of words here. The first is called a period. All right? And periods are horizontal rows. So they're horizontal. And so if you're looking at your periodic table, notice you've got 1, 2, 3, 4, 5, 6, 7 of them. So you could actually draw all of those out because you know you've got 7 rows on your periodic table. And the periods are energy levels. They're energy levels. So again, I'm going to go back here for a second. I'm going to draw Bohr's model of an atom and give me, let's say I'm going to get 2 energy levels. Let's go ahead and put 2 electrons here, and I'm going to put 1 there. Now, something I didn't talk about earlier in Bohr's model is that we do have a word that we want to introduce here, and it's called a valence electron. It's called a valence electron. And a valence electron is actually an electron on the outermost energy level, right? And so what we're doing here is we're looking this electron right here. Notice it's on the outermost energy level. That is my valence electron. So I'm going to call it valence electron. And I can have more than one of them as long as they're on that outermost energy level. All right? And so nothing crazy here, but remember my periods, now I'm going to reframe it or rephrase this. My periods are energy levels of my valence electrons. So my energy levels of my valence electron. And I'm going to abbreviate that VE. All right? So nothing crazy. So now what I want to do is I want to take a look and say, all right, I've got a valence electron on the second energy level. That means I'm somewhere in that period. The element that I've drawn there is somewhere in that period. All right? Now I'm going to add another word to your vocabulary, and it's going to be groups. All right? Groups are my vertical columns. My vertical columns. Groups are my vertical columns, and they represent the number of valence electrons for any given element. And the cool thing about this is that everything inside of your groups are the same. And so this very first group, right, a group is up and down. My very first group, they've got one valence electron. My second group has two valence electrons. Remember I told you we were going to skip the middle here. I've got 3 valence electrons, then 4 valence electrons, then 5. You see a pattern here, don't you? 6, 7 valence electrons, and then over here at the end I've got 8 valence electrons. And so notice the groups tell me the number of valence electrons. So now I'm looking here and I'm saying, okay, I see a valence electron on the second energy level, so I know I'm here, and then I've only got one of them, and so bang, I am actually looking at a lithium atom. That Bohr model is of lithium. All right. Okay, so lots of things I just threw at you there, ladies and gentlemen. Get down your questions. We'll talk about this stuff in class. Man, if you need to, listen to it again. Process these notes. Get yourself some graphic organizers, Venn diagrams, whatever you got to get down to get the stuff into your head, ladies and gentlemen. We are going to start flying like we're on fire because chemistry, we burn stuff. It's fun. This is Mr. Doolin. I will see you in class.